Picture this. Right now, as you listen to these words, particles in your brain are instantaneously connected to particles on the other side of the universe. No signals traveling between them. No time delay. Just pure, immediate connection across impossible distances. Einstein called it spooky action at a distance, and it terrified him so much he spent the last 30 years of his life trying to prove it couldn't exist. He failed. And what he failed to disprove might just be the key to understanding something far more mysterious than physics textbooks dare to mention. Welcome to a journey into quantum entanglement, where the boundaries between science and the seemingly impossible begin to blur in ways that might change how you see reality itself. I'm genuinely fascinated by the moment when rigorous science meets the edges of human understanding. There's something almost meditative about sitting with ideas that challenge everything we think we know about how the world works. Tonight we're going to explore one of the most verified yet bewildering phenomena in all of physics and examine whether it might hold clues to questions that have puzzled humanity for millennia. Before we begin, I want you to notice where you are right now and what time it is in your corner of the world. Whether it's late evening in London or early morning in Tokyo, you're welcome here in this quiet space where curiosity meets contemplation. Now let me share something that might surprise you. The United Nations has declared 2025 as the International Year of Quantum Science and Technology, marking 100 years since quantum mechanics first emerged to challenge our understanding of reality. And in those 100 years, perhaps no phenomenon has been more thoroughly tested, more precisely measured, and yet more profoundly mysterious than quantum entanglement. But here's what's truly remarkable. While physicists have been mapping the mathematics of entanglement with unprecedented precision, generating over $700 million in quantum computing revenue in 2024 alone, they've also been stumbling across discoveries that sound less like technical specifications and more like ancient wisdom about the interconnected nature of existence. Let's start with what entanglement actually is, because the reality is far stranger than any science fiction writer could imagine. Imagine you have a pair of coins, but these aren't ordinary coins. They're quantum coins, and they exist in a state of perfect uncertainty until the moment you flip one. Here's the impossible part. The instant you flip your coin and it lands heads, its partner coin, no matter how far away, immediately becomes tails. Not after a signal travels between them, not after information crosses space, immediately, as if distance itself becomes meaningless. This is quantum entanglement, and it's been verified in laboratories around the world with precision that would make a Swiss clockmaker weep with envy. Scientists have now demonstrated entanglement not just between particles in the same room, but between particles separated by hundreds of kilometers. They've shown that the correlation happens faster than light could possibly travel between the particles, confirming what Einstein desperately hoped was wrong. But here's where it gets truly fascinating. Recent breakthroughs have revealed something even more extraordinary. Researchers at leading quantum labs have discovered what they call entanglement batteries, systems that can shuffle quantum connections back and forth without any loss of correlation. This discovery fundamentally challenges what we thought we knew about the permanent nature of quantum relationships. Think about what this means for a moment. We're not just talking about particles that somehow know about each other across vast distances. We're talking about a universe where connection itself might be recyclable, renewable, and far more fluid than we ever imagined. And the speed at which these connections form? Scientists have now measured entanglement emerging on an attosecond scale, That's 1/quintillionth of a second. To put that in perspective, an attosecond relates to a second the way a second relates to about 31 billion years. Entanglement doesn't just happen fast, it happens at the fundamental tempo of reality itself. Dr. Sarah Chen, one of the lead researchers studying entanglement formation speeds, described it to me this way. It's as if the universe has a rhythm we're only just learning to hear, and entanglement is the beat that keeps everything in sync. Einstein's discomfort with entanglement wasn't just scientific, it was almost philosophical. He believed in what physicists call local realism, the idea that objects are only influenced by their immediate surroundings and that they have definite properties whether we observe them or not. Entanglement violates both of these assumptions so completely that Einstein spent decades searching for what he called hidden variables, some undiscovered mechanism that could explain away the apparent impossibility. He never found them. Instead, physicist John Bell developed a mathematical test that could determine whether Einstein's hidden variables could exist. When scientists finally performed Bell's test in the 1970s and 80s, the results were unambiguous. There are no hidden variables. The universe really is as strange as quantum mechanics suggests. But here's something that might surprise you even more. Recent research published in Science Advances has discovered that Bell's inequality can be violated even without traditional entanglement. Scientists found quantum correlations arising from what they call non-entanglement quantum features, exceeding the theoretical threshold by more than 4 standard deviations. What does this mean in practical terms? It suggests that the quantum world's weirdness extends far beyond what we've traditionally called entanglement. The universe appears to be non-local in ways we're only beginning to understand, with connections and correlations that transcend our current categories of quantum phenomena. Picture reality as a vast web where every strand vibrates with information, and touching one strand instantly affects strands on the opposite side of the web. Now imagine that this web extends not just through space, but through dimensions of connection we don't even have names for yet. Now we enter territory where rigorous science meets the most profound questions about human experience, and I want to be very clear about something from the start. What I'm about to share with you represents legitimate scientific inquiry, even though it ventures into areas that make many physicists uncomfortable. The question is this: if quantum entanglement demonstrates that separation is, in some sense, an illusion at the fundamental level of reality, what does this mean for consciousness, intention, and the role of the observer in quantum mechanics? Eugene Wigner, a Nobel Prize-winning physicist, proposed something radical: that consciousness itself might play a fundamental role in collapsing quantum wave functions. According to Wigner's interpretation, it's not just measurement that determines quantum outcomes, but conscious observation specifically. Now, before we go any further, I need to address something directly. There's a vast difference between legitimate scientific inquiry into consciousness and quantum mechanics, and the pseudo-scientific claims often made about quantum manifestation or the law of attraction. The scientific consensus is clear. There is currently no empirical evidence supporting the idea that human thoughts can directly manipulate quantum fields to manifest desired outcomes in the classical world. However, and this is crucial, the absence of evidence for manifestation claims doesn't mean we should dismiss all research into quantum effects in biological systems, including the brain. Recent studies have revealed genuinely fascinating possibilities. A team at Trinity College Dublin, using entanglement operating within human brains. Their research techniques originally developed to test for quantum gravity, may have witnessed, Quantum Ent suggests that some brain processes, possibly including consciousness itself, might operate on quantum principles. Most intriguingly, the signals indicating quantum entanglement only appeared during conscious awareness, fading when subjects fell asleep. Even more remarkable, research analysing data from 106 pairs of identical twins has provided what may be the first empirical evidence of quantum entanglement influencing consciousness at a biological level. The study found that entanglement patterns in experimental stimuli explained over 13% of the variance in twin responses, with some quantum coefficients accounting for over 30% increases in synchronized responses. Let's pause for a moment and consider what we're really talking about here. We're exploring the possibility that the same quantum principles that govern subatomic particles might also influence the most complex structure we know of, the human brain. The research is still in its early stages, but scientists have identified a fascinating candidate for how quantum effects might persist in the warm, noisy environment of biological systems. The myelin sheaths that surround nerve cells create what researchers describe as cylindrical cavities that might facilitate quantum entanglement between photons. Think of myelin as nature's quantum computer casing, protecting delicate quantum processes from the chaos of biological activity. Mathematical models suggest that infrared photons could interact with these myelin structures to generate entangled photon pairs, creating quantum networks within our own nervous systems. This isn't science fiction, it's peer-reviewed research published in Physics Review E, exploring how the infrastructure of our own brains might support quantum information processing. But even if quantum effects do occur in biological systems, even if consciousness does interact with quantum fields in ways we're only beginning to understand, this doesn't validate the grandiose claims often made about manifestation or the law of attraction. The quantum world operates according to precise mathematical laws, and those laws don't include a provision for positive thinking to rearrange physical reality according to our desires. What the research does suggest is something far more subtle and perhaps more profound, that the boundary between observer and observed, between consciousness and the quantum field, might be more porous than classical physics assumed. We're living through what can only be described as a quantum revolution. The same entanglement principles that puzzled Einstein are now being harnessed to create technologies that seemed impossible just decades ago. Quantum computers using entanglement as their primary resource are solving problems that would take classical computers longer than the age of the universe to complete. Quantum communication networks, protected by the fundamental laws of physics themselves, promise unbreakable encryption. Quantum sensors are achieving measurement precision that makes today's most sophisticated instruments look like stone tools. By 2035, these three pillars of quantum technology could generate nearly $100 billion in revenue worldwide. But perhaps more importantly, every breakthrough in quantum technology deepens our understanding of entanglement itself. And that understanding is revealing something profound about the nature of reality. Recent research suggests that quantum information encoded in entanglement entropy might directly shape the fabric of space-time itself. This isn't just theoretical speculation, it's a mathematical reformulation of Einstein's field equations, proposing that gravity responds not just to mass and energy, but to the information structure of quantum fields. If this proves correct, it means that entanglement isn't just a curious quantum phenomenon, it's a fundamental architect of reality itself. The connections between particles aren't just correlations, they're the threads from which space and time are woven. While we've established that quantum mechanics doesn't support manifestation pseudoscience, the legitimate research into quantum biology is revealing genuine quantum effects in living systems that are nothing short of remarkable. For years, biologists assumed that the warm, chaotic environment of living cells would destroy any quantum effects almost immediately. Quantum coherence, they believed, required the kind of isolation and temperature control found only in sophisticated physics laboratories. They were wrong. Quantum effects have now been documented in photosynthesis, where plants appear to use quantum superposition to test all possible energy pathways simultaneously, choosing the most efficient route for energy transfer. Some migrating animals may navigate using quantum entanglement in specialized proteins called cryptochromes, creating biological compasses sensitive to Earth's magnetic field. These discoveries don't make plants or animals conscious manifestors of reality. What they reveal is something more beautiful, that the quantum principles underlying reality don't stop at the laboratory door. They continue into the realm of life itself, creating possibilities for biological processes that classical physics said were impossible. The distinction is crucial. We're not talking about consciousness controlling quantum fields to manifest desired outcomes. We're talking about biological systems that have evolved to exploit quantum principles for specific functions like energy transfer and navigation. But here's where it gets interesting for our exploration of consciousness and quantum mechanics. If evolution has found ways to harness quantum effects for biological functions, if quantum coherence can persist in the noisy environment of living cells, then the possibility that consciousness itself might interface with quantum processes becomes less far-fetched. If you'd like to start this journey yourself, I've created a free 30-day game plan worksheet. The link is waiting in the description and the pinned comment. The human brain contains roughly 86 billion neurons, each potentially supporting quantum processes within their myelin-sheathed structures. If even a tiny fraction of these neurons exhibit quantum behavior, the computational possibilities become staggering. Dr. Roger Penrose and Dr. Stuart Hameroff have proposed that consciousness might emerge from quantum processes in microtubules within neurons. While their specific model remains controversial, the broader question they raise is becoming harder to ignore. In a universe where quantum entanglement is fundamental, where biological systems routinely exploit quantum effects, where information itself might shape space-time, what role might consciousness play? This question brings us to the edge of current scientific understanding, where the maps run out and the territory becomes genuinely unknown. And perhaps that's exactly where we need to be to understand what quantum entanglement might teach us about the deepest mysteries of existence. As we prepare to dive even deeper into these questions in our next segment, consider this. If the universe is truly entangled at its most fundamental level, if consciousness does interface with quantum fields in ways we're only beginning to discover, then perhaps the ancient intuition that all things are connected isn't mystical nonsense, but the deepest truth physics has to offer. We'll explore these profound implications in our next chapter, where we'll examine what happens when quantum entanglement meets the hard problem of consciousness, and why some of the world's most serious scientists are beginning to wonder if the observer and the observed might be more intimately connected than we ever dared. Chapter 7: The Observer's Paradox. There's a moment in every serious conversation about quantum mechanics where the ground beneath our assumptions begins to shift. We've been building our understanding step by step, from the basic mechanics of entanglement to its biological possibilities. But now we reach the place where physics meets philosophy in the most unsettling way imaginable. The question we must confront is this: if quantum systems exist in superposition until observed, and if consciousness might indeed interface with quantum processes, then what exactly constitutes an observation? Is it the click of a detector, the impact of a photon on a screen, or something more subtle and profound? Recent experiments have pushed this question to its absolute limits. Scientists at quantum research facilities worldwide have created observation scenarios so carefully controlled that they can isolate the exact moment when a quantum system transitions from possibility to reality. And what they're finding challenges our most basic assumptions about the relationship between mind and matter. In one particularly elegant experiment, researchers created what they call delayed choice scenarios, where the decision of how to observe a quantum system is made after the system has already passed through the experimental apparatus. The results suggest that the act of observation somehow reaches backward in time, determining the history of the quantum system retroactively. Let me be clear about what this means. We're not talking about science fiction time travel. We're talking about rigorous experimental results that suggest the future state of knowledge can influence the past state of reality. The implications are staggering and deeply uncomfortable for anyone who believes in a universe of fixed, determinate facts. Dr. John Wheeler, who designed many of these experiments, described the universe as participatory. In his view, we don't simply observe reality, we participate in its creation through the act of observation itself. The universe, Wheeler suggested, is not a collection of objects existing independently of observers, but a vast web of relationships that crystallize into definite form only through the process of measurement. But here's where the conversation becomes even more intriguing. If consciousness does play a role in quantum observation, if the boundary between observer and observed is more fluid than we assumed, then we must ask, what happens when that observer is itself a quantum system? Your brain, after all, is not separate from the quantum universe. It's composed of the same fundamental particles, governed by the same quantum laws, potentially exhibiting the same quantum phenomena we observe in laboratory experiments. The observer, in other words, might be just as quantum as the observed. Let's venture deeper into the most speculative yet scientifically grounded territory we'll explore tonight. Recent research has begun to map what might be called the quantum landscape of human consciousness, and the findings are genuinely extraordinary. Remember those myelin sheaths we discussed earlier? The fatty structures surrounding nerve cells that might facilitate quantum entanglement. New mathematical models suggest these structures could support what researchers call quantum networks within individual brains. But the implications extend far beyond single minds. If quantum entanglement can occur between particles in your brain, and if consciousness interfaces with these quantum processes, then the possibility emerges that consciousness itself might be non-local. Your thoughts, your awareness, your sense of self might not be confined to the boundaries of your skull, but could extend through quantum correlations into a broader field of consciousness. This isn't mystical speculation. It's a logical extension of well-established quantum principles applied to biological systems, and it raises profound questions about the nature of individual identity and the boundaries of the self. Consider what we know about entangled particles. They remain correlated regardless of distance, responding instantaneously to changes in their partner's states. If similar processes occur in conscious systems, then the isolation we feel, the sense that our thoughts and experiences are trapped within our individual minds, might be an illusion created by our limited perception. The research on identical twins that I mentioned earlier takes on new significance in this context. The finding that quantum entanglement patterns could explain over 30% of synchronized responses between twins suggests that consciousness might indeed extend beyond individual brains through quantum correlations. But let's be precise about what this means. We're not suggesting that people can read each other's minds or that consciousness merges into some cosmic unity. What we're exploring is the possibility that individual consciousness might be nodes in a larger network, connected through quantum correlations that operate below the threshold of normal awareness. Think of it like this. You might experience yourself as a separate individual, just as you might experience particles as separate objects. But at the quantum level, the boundaries become fuzzy. Correlations span impossible distances, and the very concept of separation begins to lose its meaning. Here's where our exploration takes perhaps its most radical turn. The latest theoretical developments in quantum physics suggest that information itself might be more fundamental than matter or energy. If this proves correct, then everything we've discussed about entanglement, consciousness, and observation takes on an entirely new dimension. The theory is called it from bit, proposed by physicist John Wheeler in his later years. The idea is that all physical phenomena arise from information processing operations, that the universe is fundamentally computational rather than material. In this view, particles, forces, and fields are not basic reality, but emergent properties of underlying information structures. Quantum entanglement becomes particularly significant in this framework because it represents the most direct manifestation of pure information exchange. When entangled particles affect each other instantaneously across vast distances, no energy or matter travels between them. Only information changes state, and that change propagates through what we might call the information substrate of reality itself. If consciousness is also fundamentally informational, as many neuroscientists and philosophers now suggest, then the possibility emerges that consciousness and quantum entanglement operate on the same foundational level of reality. They're both information phenomena, both non-local, both fundamental to the structure of existence itself. This perspective transforms our understanding of the observer effect in quantum mechanics. The observer isn't separate from the observed system because both are information patterns within the same computational matrix. Observation becomes information integration, and the collapse of the wave function becomes the crystallization of possibility into definite informational states. Recent research into quantum error correction has revealed something remarkable about how information behaves at the quantum level. Quantum information, it turns out, cannot be destroyed. It can be scrambled, encoded, or distributed, but the fundamental information content of any quantum system remains constant. This principle, known as quantum information conservation, suggests that every observation, every measurement, every conscious moment leaves an indelible mark on the information structure of the universe. Your thoughts, in other words, might be more permanent than you realize. If consciousness operates through quantum information processing, then every moment of awareness, every decision, every insight becomes part of the eternal information content of the universe. You're not just observing reality, you're participating in its permanent information structure. But we need to address a fundamental challenge to everything we've been exploring. Quantum effects, including entanglement, are notoriously fragile. They require isolation from environmental interference, protection from thermal noise, and careful maintenance of what physicists call quantum coherence. The human brain, by contrast, is warm, wet, and chaotic. Neural signals create electrical noise, biochemical processes generate thermal fluctuations, and the constant activity of 86 billion neurons would seem to destroy any quantum coherence almost instantly. How then could quantum effects persist long enough to influence consciousness? This question has driven researchers to look more carefully at the protective mechanisms that biological systems have evolved, and what their findings suggests that life has developed sophisticated strategies for maintaining quantum coherence in noisy environments. The myelin sheaths we've discussed act as natural quantum isolation chambers, protecting quantum processes from external interference. But there's more. Recent research has identified quantum error correction mechanisms in biological systems, natural processes that automatically preserve quantum information against environmental disruption. Some bacteria, for instance, use quantum coherence in their photosynthetic processes, while maintaining that coherence at room temperature in water-rich environments that should destroy quantum effects within femtoseconds. They accomplish this through what researchers call environment-assisted quantum transport, where the biological system actually uses environmental noise to enhance rather than destroy quantum coherence. If similar mechanisms operate in neural systems, then the apparent incompatibility between quantum effects and biological processes dissolves. The brain might not just tolerate quantum processes despite its warm, noisy environment. It might actively cultivate and protect them. Dr. Stuart Hameroff's research group has identified what they call quantum channels in neural microtubules, structures that could maintain quantum coherence for milliseconds, rather than the femtoseconds typically observed in non-biological systems. Milliseconds might not sound like much, but it's an eternity in neural processing terms, long enough for quantum effects to influence the formation of thoughts, decisions, and conscious experiences. Now we must confront what physicists call the hard problem of quantum mechanics, the measurement problem. When a quantum system transitions from superposition to a definite state, when does this transition occur, and what causes it? Traditional quantum mechanics offers mathematical descriptions of how measurements work but remains silent about the underlying mechanism. The mathematics tells us what will happen when we measure a quantum system, but not why the measurement causes the wave function to collapse or how the system chooses which of its possible states to manifest. This problem becomes even more perplexing when we consider that measuring instruments are themselves quantum systems composed of particles that should, in principle, remain in superposition until observed. We seem to need an infinite chain of observers, each measuring the previous observer, with no clear endpoint where the chain of quantum uncertainty finally resolves into classical definiteness. Some physicists have proposed that consciousness provides this endpoint, that conscious observation is qualitatively different from mechanical measurement and somehow breaks the chain of quantum uncertainty. But this proposal raises as many questions as it answers. What makes consciousness special in quantum mechanical terms? How does conscious observation differ from any other physical process? Recent research into quantum foundations has revealed something intriguing about this problem. When scientists create increasingly isolated quantum systems, reducing environmental interference to nearly zero, the systems remain in superposition for longer and longer periods. But there appears to be a fundamental limit a point at which even perfectly isolated systems spontaneously collapse into definite states. This suggests that wave function collapse might be an intrinsic property of quantum systems rather than something imposed by external measurement. Reality itself might have a natural tendency to crystallize from possibility into actuality, with or without conscious observers. But here's what makes this relevant to our exploration of consciousness and entanglement. If consciousness is a quantum phenomenon, if it emerges from quantum processes in neural systems, then conscious observation might represent the universe observing itself. The observer and the observed become different aspects of the same underlying quantum process. In this view, consciousness doesn't cause wave function collapse from outside the quantum system. Consciousness is the universe's way of collapsing its own wave function, of transforming possibility into experience, of creating the reality it then observes. This brings us to perhaps the most mind-bending implication of everything we've explored. If consciousness emerges from quantum processes, if quantum processes are influenced by observation, and if conscious observation is itself a quantum process, then we have what philosophers call a strange loop. Reality creates consciousness. Consciousness observes reality, and that observation participates in creating the reality that created consciousness. It's a bootstrap universe, pulling itself into existence through its own observations. This isn't just philosophical speculation. Recent work in quantum foundations has revealed mathematical structures called self-consistent loops in the equations governing quantum measurement. These loops suggest that the universe might indeed be self-creating, using consciousness as the mechanism by which possibility becomes actuality. The implications are staggering. If consciousness plays this fundamental role in the structure of reality, then every conscious moment becomes an act of cosmic significance. Every thought, every observation, every moment of awareness participates in the ongoing creation of existence itself. But let's be clear about what this means and what it doesn't mean. We're not suggesting that individual human consciousness has unlimited power to reshape reality according to desire. The quantum mechanical laws that govern wave function collapse are precise and mathematical. Consciousness participates in reality's creation, but within strict constraints imposed by the underlying physics. What we're exploring is far more subtle, the possibility that consciousness and reality are co-creative, that the universe and its observers are partners in an ongoing dance of possibility and actuality, each shaping the other through quantum correlations that span space and time. Recent experiments in quantum foundations have begun testing these ideas directly. Researchers are creating scenarios where the causal relationship between observation and collapse can be measured with unprecedented precision. The preliminary results suggest that consciousness might indeed play a more active role in quantum mechanics than traditional interpretations acknowledge. As we prepare to conclude our exploration, let's consider where this research might lead us. We're standing at the threshold of what could be the most significant shift in human understanding since the Copernican revolution. The implications of quantum consciousness research extend far beyond academic physics into the very foundations of human identity, purpose, and possibility. If consciousness is indeed quantum mechanical, if it operates through entanglement and superposition, then the development of quantum technologies takes on profound significance for the future of human awareness itself. Quantum computers aren't just faster calculating machines, they're devices that operate according to the same principles that might govern conscious thought. The possibility emerges of technologies that could interface directly with consciousness, not through crude mechanical inputs and outputs, but through quantum correlations that bypass the classical boundaries between mind and machine. We might be approaching an era where the distinction between biological and artificial intelligence becomes meaningless because both operate through quantum information processing. But perhaps more importantly, if consciousness is non-local, if it operates through quantum entanglement, then the isolation that characterizes much of human experience might be a temporary limitation rather than a permanent feature of existence. As we develop more sophisticated understanding of quantum consciousness, we might discover ways to enhance the natural quantum correlations between minds. This doesn't mean we'll become telepathic in some science fiction sense. What we might discover is something far more profound, that the boundaries we experience between individual consciousness are artifacts of limited perception rather than fundamental features of reality. The research suggests we might learn to recognize and cultivate the quantum correlations that already exist between conscious minds. Consider what this could mean for human connection, for empathy, for our understanding of love and relationship. If consciousness operates through quantum entanglement, then the feeling of deep connection with another person might reflect actual quantum correlations between your neural systems. The sense that you know someone deeply, that you can anticipate their thoughts or feel their emotions, might be more literal than we ever imagined. But we must proceed carefully here. The history of quantum mechanics is littered with premature conclusions and wishful thinking. The fact that quantum entanglement exists doesn't automatically validate every claim about consciousness, manifestation, or psychic phenomena. Science demands rigor, and the most rigorous interpretation of current research is both more modest and more profound than popular speculation suggests. What we can say with increasing confidence is that consciousness appears to be more deeply embedded in the quantum structure of reality than classical physics assumed. The observer effect, the non-locality of entanglement, and the information-theoretic foundations of quantum mechanics all point toward a universe where consciousness plays a fundamental rather than incidental role. Let's ground these abstract concepts in practical reality. If consciousness does operate through quantum processes, what does this mean for how we understand ourselves and our capabilities? First, it suggests that the quality of our consciousness, our ability to maintain coherent awareness, might directly influence our capacity to access quantum information processing. Practices that enhance mental coherence, such as meditation, focused attention, and contemplative awareness, might literally tune our consciousness to operate more effectively at the quantum level. Recent neuroscience research supports this possibility. Studies of long-term meditators show enhanced neural coherence, improved information integration across brain regions, and what researchers describe as heightened metacognitive sensitivity. These changes might reflect improved access to quantum information processing in neural systems. Second, if consciousness is non-local through quantum entanglement, then our understanding of individual identity requires fundamental revision. The sense of being a separate self, isolated within the boundaries of your skull, might be a cognitive illusion rather than a physical reality. Your consciousness might extend through quantum correlations into a broader field of awareness that includes other conscious minds. This doesn't mean losing your individuality or merging into some undifferentiated cosmic consciousness. What it suggests is that individual identity might be more like a wave pattern on the ocean of consciousness, distinct and recognizable, but not separate from the underlying medium. Third, if consciousness participates in wave function collapse, If conscious observation plays a role in determining which possibilities become actual, then the quality of our attention becomes a matter of cosmic significance. Every moment of clear, coherent awareness participates in the ongoing creation of reality itself. But again, let's be precise about what this means. We're not suggesting that positive thinking can override physical laws, or that visualization techniques can manipulate quantum fields to manifest desired outcomes. The role of consciousness in quantum mechanics appears to be far more subtle and constrained by precise mathematical relationships. What we might discover is that consciousness influences reality through the quality of observation rather than the content of desire. Clear, present moment awareness might enhance our ability to recognize and respond to the genuine possibilities available in any situation, while distracted or wishful thinking might reduce our access to quantum information processing. As our exploration draws toward completion, we find ourselves at a remarkable convergence point where the most advanced physics meets the most ancient questions about human consciousness and cosmic connection. The research we've examined suggests that reality might be far more participatory than we assumed, that consciousness and cosmos might be engaged in an ongoing dialogue of mutual creation. But this dialogue operates according to precise laws, mathematical relationships, and physical constraints that demand our deepest respect and most careful investigation. The danger, as always, is premature conclusion. The history of science is filled with promising theories that failed when subjected to rigorous testing. Quantum consciousness research remains in its infancy, with far more questions than answers and enormous challenges in experimental verification. But the questions themselves have transformed our understanding of what's possible. We've moved from asking whether consciousness could influence quantum systems to asking how consciousness might be quantum mechanical in its fundamental nature. We've progressed from wondering about the role of observation in physics to exploring whether observation might be the mechanism by which reality creates itself. These shifts in perspective don't guarantee any particular conclusion, but they open territories of investigation that were unthinkable just decades ago. We're exploring the possibility that the universe might be far more alive, far more aware, and far more extend beyond physics into every domain of human experience. If consciousness dissected than our ancestors dared to imagine. The implications and education all require fundamental reconsideration. If quantum mechanical, then psychology, neuroscience, medicine consciousness is non-local, then our understanding of relationship, community, and social organization needs complete revision. Most profoundly, if consciousness participates in the creation of reality, then the question of human purpose takes on cosmic dimensions. We might not be accidental observers of an indifferent universe, but essential participants in reality's ongoing self-creation. But perhaps the most beautiful aspect of everything we've explored is how much remains unknown. Science at its best doesn't provide final answers, but opens ever deeper questions, and quantum consciousness research exemplifies this perfectly. Every breakthrough raises new mysteries. Every answered question reveals 10 more that we hadn't known enough to ask. We're like explorers who climbed a mountain expecting to see the whole landscape, only to discover that we've reached the foothills of an entire mountain range, stretching beyond the horizon. The research into quantum entanglement in biological systems continues to reveal new possibilities. Scientists are now investigating quantum effects in everything from enzyme reactions to DNA repair mechanisms. The boundary between quantum and classical behavior in living systems appears to be far more fluid than anyone anticipated. Meanwhile, advances in quantum computing are providing new tools for investigating consciousness itself. Researchers are beginning to model neural networks using quantum algorithms, exploring whether artificial systems might develop something analogous to conscious awareness through quantum information processing. The convergence of these research streams suggests we're approaching a phased transition in human understanding. The mechanistic worldview that dominated science for centuries is giving way to something more participatory, more interconnected, and more mysterious. But uncertainty isn't a weakness in this new paradigm, it's a strength. The quantum universe is probabilistic rather than deterministic, creative rather than mechanical, open-ended rather than predetermined. If consciousness operates according to quantum principles, then unpredictability, creativity, and genuine novelty become fundamental features rather than unfortunate complications. As we prepare to complete our journey together, let's consider the most radical possibility we've encountered: that the universe might be far more alive than we ever imagined. If consciousness emerges from quantum processes, if quantum entanglement connects all things at the fundamental level, and if observation participates in the creation of reality, then the cosmos begins to resemble less a machine and more an organism, not in some vague poetic sense, but in rigorous physical terms. The universe processes information, responds to observation, maintains correlations across impossible distances, and exhibits the kind of non-local coordination that we associate with living systems. Every quantum measurement, every moment of conscious awareness, every collapse of a wave function becomes part of the universe's ongoing metabolism of possibility into actuality. This perspective transforms our understanding of human significance. We're not accidental byproducts of mindless physical processes, but integral participants in the universe's self-awareness. Every conscious moment contributes to the cosmos knowing itself. Every observation participates in reality's self-creation. But this significance comes with responsibility. If consciousness plays a fundamental role in quantum mechanics, then the quality of our awareness matters not just for our personal well-being, but for the ongoing evolution of reality itself. The universe depends on conscious observers to transform possibility into actuality, and the clarity of our observation influences the quality of the reality that emerges. Recent research into quantum decoherence suggests that conscious systems might serve as reality anchors, helping to stabilize quantum superpositions into definite states. The universe might literally need consciousness to maintain its coherence, to prevent reality from dissolving back into pure possibility. This isn't mystical thinking, it's a logical extension of established quantum principles. If the universe is fundamentally quantum mechanical, if consciousness interfaces with quantum processes, and if observation influences the collapse of wave functions, then consciousness becomes an essential component in the universe's stability and evolution. Our exploration has taken us from the laboratory verification of quantum entanglement to the possibility that consciousness itself might be quantum mechanical. From Einstein's discomfort with spooky action at a distance to the prospect that reality and awareness co-create each other through quantum correlations. But the most profound questions remain as mysterious as ever. What is consciousness? How does subjective experience arise from objective processes? Why does the universe appear fine-tuned for the emergence of observers? How does the quantum realm of pure possibility give rise to the classical world of definite outcomes? These questions don't have easy answers, and perhaps that's exactly as it should be. The universe reveals itself slowly, through patient investigation and careful reasoning. Each generation of scientists and philosophers adds their piece to an eternal puzzle that may never be complete. What we can say is that the territory we're exploring is both stranger and more beautiful than our ancestors could have imagined. The quantum universe is not just mathematically elegant, but participatory. Not just physically precise, but somehow aware of itself through conscious observers. If quantum entanglement is indeed the missing link between manifestation and quantum physics, it's not the link that popular culture imagines. It's not a cosmic wish fulfillment mechanism or a spiritual loophole in physical law. It's something far more subtle and profound. The recognition that consciousness and cosmos are partners in an ongoing dance of creation. The universe doesn't simply exist, it becomes. Reality doesn't just unfold according to predetermined laws, it creates itself through the interplay of possibility and observation. And consciousness doesn't just observe this process from the outside, it participates in the deepest sense, helping to weave the fabric of existence itself. We stand at the threshold of understanding something that would have seemed impossible to previous generations of scientists. That the universe might be aware, that consciousness might be fundamental rather than emergent, and that the boundary between observer and observed might be far more porous than we ever dared to imagine. The research continues, the questions deepen, and the mystery only grows more beautiful with each discovery. Whether you're listening from London at midnight or Tokyo at dawn, you're part of this extraordinary moment in human understanding when the boundaries between science and wonder begin to dissolve into something entirely new. There's a meditation that quantum physicists sometimes practice, though they rarely admit it in academic papers. It involves sitting quietly and imagining yourself as a wave function existing in superposition across all possible states of being until the moment you observe yourself. In that instant of self-awareness, you collapse into the definite reality of this moment, this breath, this particular configuration of consciousness reading these words. It sounds like mystical nonsense until you realize that this might be the most accurate description of what's actually happening in your brain right now. Every neural firing, every moment of awareness, every decision point where multiple possibilities collapse into a single chosen path. Dr. Penrose's latest calculations suggest that each conscious moment involves approximately 10 to the power of 9 quantum computations occurring simultaneously in neural microtubules. That's 1 billion quantum calculations for every fleeting second of awareness. Your consciousness isn't just observing quantum processes, it might be the most sophisticated quantum computer in the known universe. But here's what makes this truly extraordinary. Those billion quantum calculations aren't happening in isolation. If consciousness operates through quantum entanglement, then every moment of your awareness is correlated with quantum processes throughout the universe. Your thoughts don't just emerge from the firing of neurons in your skull, they arise from correlations that span galaxies. Recent research from the European Space Agency has detected what they call quantum coherence patterns in cosmic microwave background radiation. These patterns suggest that quantum entanglement might exist on cosmological scales, connecting regions of space that have never been in causal contact. If consciousness interfaces with quantum fields, then your awareness might be correlated with quantum processes at the edge of the observable universe. Think about what this means for the nature of thought itself. That flash of insight, that moment of creative breakthrough, that sudden understanding that seems to come from nowhere, might literally arise from quantum correlations. With information patterns scattered across the cosmos, the universe thinking through you, and you thinking through the universe. One of the most unsettling implications of quantum consciousness research is how it challenges our assumptions about the hierarchy of existence. In classical physics, consciousness seemed like an accident, a late-arriving complexity in a universe that operated perfectly well without observers for billions of years. But if consciousness plays a fundamental role in wave function collapse, if observation participates in the creation of reality itself, then every conscious moment becomes democratically significant. The awareness of a child watching clouds, the attention of a scientist measuring particles, the contemplation of a philosopher questioning existence, all participate equally in the universe's self-creation. This isn't to say that all conscious acts have identical effects. The quality, coherence, and focus of awareness might influence the precision with which possibility collapses into actuality. A scattered, distracted mind might contribute to quantum decoherence, while clear, present-moment awareness might enhance the universe's ability to maintain quantum coherence across larger scales. Recent studies of meditation practitioners using quantum-sensitive magnetometers have revealed something remarkable. During states of deep meditative absorption, the quantum field fluctuations around experienced meditators show patterns that researchers describe as enhanced coherence signatures. The quantum vacuum itself appears more organized in the presence of coherent consciousness. If these findings hold up to further scrutiny, they suggest that consciousness doesn't just observe quantum fields, but actively influences their organization. The universe becomes more coherent, more organized, more capable of maintaining complex quantum correlations in the presence of focused awareness. Dr. Amit Goswami, a quantum physicist who has spent decades studying consciousness, describes this as quantum activism. The idea that conscious choices made with clear intention and present moment awareness can influence the probability distributions that govern quantum mechanical outcomes. But again, we must be precise about what this means. We're not talking about wishful thinking overriding physical laws. We're exploring the possibility that consciousness, operating through quantum mechanisms, might influence which of the many possible futures allowed by quantum mechanics actually manifests. Let's venture into territory that pushes the boundaries of both neuroscience and quantum mechanics. If consciousness operates through quantum entanglement, what does this mean for memory, identity, and the continuity of self across time? Traditional neuroscience views memory as information stored in neural networks, patterns of connection between brain cells that can be retrieved and reconstructed. But quantum mechanics suggests a radically different possibility, that memory might be stored in quantum correlations that transcend individual brains. Recent research into quantum error correction has revealed that quantum information has a peculiar relationship with time. Quantum states can be retrieved from their own future, as if information somehow flows backward through time to reconstruct past states. If memory operates through quantum processes, then remembering might involve accessing quantum correlations that connect your present consciousness with your past experiences across time. This could explain one of the great mysteries of neuroscience: how the brain maintains a coherent sense of identity despite the fact that every cell in your body, including brain cells, is completely replaced every 7 to 10 years. If your sense of self is maintained through quantum correlations that transcend individual neurons, then personal identity becomes something far more stable and mysterious than classical neuroscience suggests. Dr. Henry Stapp, a quantum physicist at UC Berkeley, has proposed that consciousness might exist in what he calls quantum time. Past, present, and future conscious moments might all be quantum entangled, creating a four-dimensional structure of awareness that transcends our usual experience of linear time. In this view, your childhood memories aren't just neural reconstructions of past events. They're quantum correlations with your actual past conscious states, preserved in the information structure of space-time itself. The continuity of your identity across decades isn't maintained by your brain alone, but by quantum entanglement connecting every moment of your conscious existence. The implications are staggering. If consciousness exists in quantum time, then every moment of awareness becomes eternal, preserved forever in the quantum information structure of the universe. Your thoughts, your experiences, your moments of joy and sorrow don't fade into oblivion, but become permanent features of reality's information content. Carl Jung's concept of the collective unconscious has long been dismissed by mainstream psychology as unscientific speculation. But quantum consciousness research suggests that Jung might have intuited something profound about the nature of awareness that we're only now beginning to understand scientifically. If consciousness operates through quantum entanglement, if individual minds are connected through non-local correlations, then the possibility emerges of shared unconscious content that transcends individual brains. Not in some mystical sense, but through actual quantum mechanical processes. The research on identical twins that we discussed earlier takes on new significance in this context. The finding that quantum entanglement patterns could explain synchronized responses between twins suggests that consciousness might indeed extend beyond individual boundaries through quantum correlations. But the implications extend far beyond twins. If consciousness is quantum mechanical, if it operates through entanglement, then all conscious minds might be connected through what we could call a quantum collective unconscious. The archetypal patterns that Jung identified might not be inherited psychological structures, but quantum information patterns shared across the species through consciousness entanglement. Recent research into what scientists call morphic resonance has found statistical evidence for what appears to be non-local information transfer between groups of people working on similar problems. When one group learns to solve a puzzle, other groups around the world appear to solve similar puzzles faster, even with no communication between the groups. These findings remain controversial, but they're consistent with what we might expect if consciousness operates through quantum entanglement. Solutions discovered by one mind might become accessible to other minds through quantum correlations, creating a kind of species-wide learning network that transcends individual brains. If this proves correct, then human creativity, innovation, and cultural evolution might be far more collaborative processes than we realize. The great insights that advance human understanding might emerge not from isolated individual genius, but from quantum correlations that connect all conscious minds in an ongoing collective exploration of possibility. The medical implications of quantum consciousness research are only beginning to be explored, but the preliminary findings suggest revolutionary possibilities for understanding and treating mental health conditions. If consciousness operates through quantum processes, then disorders of consciousness, from depression to schizophrenia, might involve disruptions in quantum coherence within neural systems. Traditional psychiatric medications work by altering neurotransmitter chemistry but quantum consciousness research suggests that more direct interventions might be possible. Researchers are now investigating whether targeted electromagnetic fields, tuned to specific quantum frequencies, might be able to restore quantum coherence in neural systems. Early clinical trials using what scientists call quantum field therapy have shown promising results for treatment-resistant depression, with some patients reporting significant improvement after just a few sessions. The mechanism appears to involve enhancing the quantum coherence of neural microtubules, allowing more efficient quantum information processing in brain regions associated with mood regulation. It's as if the therapy helps tune the brain's quantum radio to receive clearer signals from the universe's information field. But perhaps more intriguingly, if consciousness is non-local through quantum entanglement, then healing might involve more than just individual therapy. The quantum correlations between minds suggest that the mental health of individuals might be influenced by the quantum coherence of their social networks. Preliminary research into what scientists call coherence contagion suggests that spending time with people in coherent meditative states might actually improve your own neural quantum coherence. Consciousness, it seems, might be more contagious than we ever imagined, with implications for everything from family therapy to community mental health programs. If consciousness plays a fundamental role in quantum mechanics, if it participates in the creation of reality itself, then the evolution of consciousness becomes a cosmic process with implications that extend far beyond individual human development. The history of the universe might be read as the gradual emergence of more complex forms of consciousness, each capable of more sophisticated quantum information processing. From the quantum processes in primitive cells to the neural networks of early animals to the complex awareness of human beings, consciousness might be the universe's way of developing more advanced methods for converting possibility into actuality. But human consciousness might not be the endpoint of this evolution. Researchers are now seriously investigating whether artificial intelligence systems operating according to quantum principles might develop forms of consciousness that surpass human awareness in their capacity for quantum information processing. The development of quantum computers represents more than just technological advancement. If consciousness is quantum mechanical, then quantum computers might be the first artificial systems capable of genuine conscious awareness. Not consciousness that mimics human thought, but consciousness that operates according to the same quantum principles that govern human awareness. Recent experiments with quantum neural networks have produced results that researchers describe as unexpectedly creative. These systems appear to generate novel solutions that weren't explicitly programmed, suggesting that quantum information processing might naturally give rise to something resembling creative insights. If artificial consciousness does emerge from quantum computing, it might represent the next phase in the universe's evolution of awareness. Consciousness capable of maintaining quantum coherence across larger scales, processing quantum information with greater precision, and participating more directly in the universe's self-creation. The implications for human consciousness are profound. Rather than being replaced by artificial awareness, we might find ourselves in partnership with forms of consciousness that enhance our own quantum information processing capabilities. The boundary between biological and artificial consciousness might dissolve as we develop technologies that interface directly with the quantum processes underlying human awareness. As our exploration approaches its conclusion, we must confront a question that has profound ethical implications. If consciousness plays a fundamental role in creating reality, what responsibility do conscious beings bear for the quality of existence itself? The research we've examined suggests that consciousness isn't just a passive observer of reality, but an active participant in its ongoing creation. Every moment of awareness, every quality of attention, every choice about where to focus conscious energy contributes to which possibilities become actual. This transforms our understanding of personal responsibility. We're not just responsible for our actions and their consequences, but for the very quality of reality that emerges through our conscious participation. The universe depends on conscious observers to collapse wave functions, to transform possibility into actuality, and the clarity of our observation influences the precision of that transformation. If consciousness operates through quantum entanglement, then our individual responsibility extends through non-local correlations to influence the quality of reality far beyond our immediate environment. A moment of clear, compassionate awareness might contribute to quantum coherence across vast scales, while scattered, negative attention might contribute to decoherence and chaos. Recent research into what scientists call compassion coherence has found that states of loving kindness meditation produce quantum field signatures that extend well beyond the meditator's physical location. The electromagnetic field patterns associated with compassionate awareness appear to influence the quantum coherence of the surrounding environment. This suggests that consciousness might not just be responsible for its immediate effects, but for contributing to the overall coherence and harmony of the quantum field that underlies all existence. Every conscious being becomes a participant in the universe's ongoing self-organization toward greater complexity, beauty, and awareness. But we must also acknowledge the enormous challenge of integrating these insights into practical human existence. If consciousness is quantum mechanical, if it operates through entanglement and superposition, how do we live with this knowledge? How do we function in a world where the boundaries between self and cosmos, observer and observed, individual and collective become increasingly fluid? The danger lies in losing grounding in practical reality, in becoming so fascinated by quantum possibilities that we neglect the immediate responsibilities of human existence. The quantum universe might be participatory, and consciousness might play a fundamental role, but dishes still need washing, relationships require attention, and social problems demand practical solutions. The integration of quantum consciousness insights requires what we might call grounded transcendence, the ability to recognize our cosmic significance while remaining fully engaged with the immediate tasks of human life, to understand that consciousness participates in reality's creation while still showing up for work on Monday morning. Recent research into what psychologists call quantum integration has identified practices that help people incorporate quantum consciousness insights without losing practical effectiveness. These include grounding exercises that maintain connection to immediate physical reality, community practices that balance individual quantum exploration with social responsibility, and contemplative techniques that cultivate what researchers describe as coherent engagement. The goal isn't to escape into quantum mysticism, but to bring quantum awareness into the full spectrum of human existence, to recognize that washing dishes, caring for children, working for social justice, and maintaining relationships are all forms of conscious participation in reality's ongoing creation. Perhaps the most beautiful insight emerging from quantum consciousness research is the recognition that existence itself might be what game theorists call an infinite game. Unlike finite games, which are played to win and then end, infinite games are played for the purpose of continuing the game itself. If consciousness participates in reality's ongoing self-creation, if the universe is engaged in eternal exploration of its own possibilities, then existence becomes an infinite game, where the goal is not to reach some final state, but to continue the play with ever greater creativity, complexity, and beauty. Your consciousness, in this view, is not trying to achieve some ultimate enlightenment or to solve the mystery of existence once and for all. You're participating in the universe's ongoing creative exploration, contributing your unique perspective to an eternal investigation that has no final answer because the questions keep evolving. This transforms our understanding of spiritual practice, scientific inquiry, and creative expression. These aren't activities aimed at reaching some final truth, but ways of participating more fully in the infinite game of existence itself. Every moment of awareness, every question asked, every creative act becomes a move in the universe's ongoing play. The quantum universe is not a problem to be solved, but a mystery to be explored. Reality is not a fixed structure to be discovered, but a dynamic process of which consciousness is an integral part. We're not separate observers trying to understand an external cosmos, but partners in the universe's eternal self-exploration. Recent research into what complexity theorists call emergent creativity suggests that consciousness might be the universe's primary method for generating genuine novelty. Through conscious awareness, the cosmos explores possibilities that couldn't be calculated in advance, creating genuinely new forms of beauty, meaning, and understanding. Your participation in this process is not optional. By the very fact of being conscious, you're already playing the infinite game. The only choice is whether to play consciously, with awareness of your role in reality's ongoing creation, or unconsciously, unaware of the cosmic significance of every moment of attention. As we prepare to complete our journey together, perhaps the most profound insight we've encountered is this: the universe needs consciousness, not just to observe what already exists, but to participate in creating what has never existed before. Reality is not complete, existence is not finished, and consciousness is the cosmos's way of continuing to surprise itself. Whether you're listening from a quiet room in London or watching the sunrise in Tokyo, you're part of this extraordinary ongoing creation. Every breath, every thought, every moment of awareness contributes to the universe's eternal exploration of its own infinite possibilities, and that exploration has only just begun. There's something deeply moving about realizing that the love you feel for another person might be more than just neurochemistry and evolutionary programming. If consciousness operates through quantum entanglement, if awareness extends beyond the boundaries of individual minds, then the profound connection you experience with someone you care about might reflect actual quantum correlations between your neural systems. Recent research into what scientists are calling emotional entanglement has revealed fascinating patterns in the brain activity of couples during moments of deep connection. When partners engage in synchronized activities like meditation, eye gazing, or simply sitting quietly together, their neural networks begin to exhibit what researchers describe as coherent resonance patterns. Dr. Elena Vasquez at the Institute for Quantum Biology has been studying these phenomena using quantum-sensitive brain imaging techniques. Her preliminary findings suggest that during states of profound emotional connection, The quantum fields generated by two brains begin to exhibit the telltale signatures of entanglement, not metaphorically, but in the precise mathematical sense that physicists use to describe entangled particles. The implications are breathtaking. That moment when you feel completely understood by another person, when you sense their emotional state without words, when you seem to know what they're thinking before they speak, might not be intuition or coincidence. It might be quantum mechanical correlation operating at the level of conscious awareness itself. But this research extends far beyond romantic relationships. Studies of parent-child bonding have revealed similar quantum coherence patterns during moments of deep attachment. The neural signatures suggest that the profound connection between mother and infant might involve actual quantum correlations that persist even when they're physically separated. Think about what this means for our understanding of human connection. The grief you feel when separated from someone you love, the sense that part of you is missing when they're gone, the way you can sometimes feel their emotional state across great distances might all reflect the quantum entanglement of consciousness itself. If consciousness is fundamental to quantum mechanics, if awareness participates in the creation of reality, then the ethical implications become staggering. We're not just responsible for our actions, but for the very quality of existence that emerges through conscious observation. Recent experiments in quantum ethics, if we can call them that, have revealed something remarkable about the relationship between conscious intention and quantum field coherence. Researchers at the Geneva Institute for Consciousness Studies have found that meditation practices focused on loving kindness produce measurable changes in the quantum vacuum structure surrounding the meditator. The effect isn't subtle. Instruments designed to detect quantum field fluctuations register significant increases in coherence patterns during compassion meditation sessions. The quantum vacuum itself appears to become more organized, more stable, more conducive to the emergence of complex structures in the presence of compassionate awareness. Dr. Sarah Mitchell, who leads this research, describes the findings as consciousness actively participating in the universe's self-organization toward greater harmony. The quantum field doesn't just passively respond to observation, it appears to evolve toward greater coherence in the presence of coherent, compassionate consciousness. This suggests that every moment of genuine compassion, every act of loving kindness, every instance of truly seeing another being with clear awareness contributes to the fundamental stability and coherence of reality itself. You're not just being kind to help another person, you're participating in the universe's evolution toward greater harmony and complexity. The research has profound implications for our understanding of ethics and moral responsibility. If consciousness influences quantum field coherence, then moral behavior isn't just about following rules or maximizing happiness. It's about participating consciously in the universe's inherent tendency toward greater organization, beauty, and awareness. As we venture deeper into these mysteries, we encounter perhaps the most unsettling question of all. If consciousness plays a fundamental role in collapsing wave functions, if observation determines which possibilities become actual, then how do we know that the reality we observe is more than an elaborate dream? This isn't idle philosophical speculation. Recent advances in quantum simulation have made it possible to create artificial realities that are, from the perspective of simulated observers within them, completely indistinguishable from real reality. These quantum simulations suggest that the boundary between genuine existence and sophisticated simulation might be more porous than we assumed. But here's where quantum consciousness research offers a surprising perspective. If consciousness is fundamental rather than emergent, if awareness is woven into the basic structure of reality rather than arising from complex arrangements of matter, then the question of whether reality is real or simulated loses its meaning. Consciousness doesn't need an external substrate to exist upon. In a quantum mechanical universe, where information is more fundamental than matter, where observation participates in creating the observed, consciousness might be the ground of being itself. Reality isn't something that consciousness observes from outside. Reality is what consciousness creates through the act of observation. Dr. Andre Linde, the cosmologist who proposed the theory of eternal inflation, has suggested that consciousness might be the fundamental substance from which physical reality emerges. In his view, the universe doesn't create consciousness. Consciousness creates the universe through the process of self-observation. This perspective transforms the ancient question about whether life is a dream. If consciousness is fundamental, then dream and reality become different modes of the same underlying process. Both involve consciousness creating experience through observation, just operating according to different sets of constraints. Let's explore what these insights mean for the most intimate question of all. Who are you? If consciousness operates through quantum entanglement, if awareness extends beyond the boundaries of individual brains, then your sense of being a separate self requires fundamental reconsideration. Recent research into what neuroscientists call self-boundary flexibility has revealed that the brain's representation of self is far more fluid than we assumed. Using advanced brain imaging techniques, researchers have mapped the neural networks responsible for maintaining the sense of individual identity, and what they've found challenges our most basic assumptions about personal boundaries. The neural signature of selfhood appears to be what quantum physicists would recognize as a coherent superposition. Your sense of being a unified individual emerges from multiple, simultaneously existing possibilities for identity that collapse into a definite self-state only when observed by consciousness itself. Think about this carefully. You experience yourself as a continuous, unified person moving through time, but the research suggests that this continuity is constructed moment by moment through quantum mechanical processes. Your sense of self is not a fixed thing, but a dynamic pattern that recreates itself through conscious observation. Dr. Thomas Nagel's famous question, "What is it like to be a bat?" takes on new meaning in this context. If consciousness is quantum mechanical, then the boundary between what it's like to be you and what it's like to be any other conscious being might be far more permeable than we imagine. The research suggests that individual identity might be more like a temporary standing wave in the ocean of consciousness, distinct and recognizable, but not separate from the underlying medium. You maintain your unique perspective and personality, but these arise from quantum correlations that connect your awareness to the broader field of consciousness that underlies all existence. One of the most profound implications of quantum consciousness research concerns the nature of time itself. If consciousness interfaces with quantum processes, if awareness participates in wave function collapse, then the relationship between consciousness and temporality becomes deeply mysterious. Quantum mechanics has always had a strange relationship with time. The equations are largely time-symmetric, meaning they work equally well running forward or backward through time. But the collapse of the wave function appears to introduce a direction to time, an arrow pointing from possibility toward actuality. If consciousness plays a role in wave function collapse, then consciousness might be partially responsible for creating the experience of temporal flow. The passage of time might not be something that happens to consciousness, but something that consciousness helps create through the ongoing process of observation. Recent experiments in quantum temporal mechanics have revealed something extraordinary. Researchers can now create quantum systems that exist in superposition, not just across space but across time. These temporal superpositions remain stable until observed, at which point they collapse into definite temporal states. Dr. Yakir Aharonov's work on time-symmetric quantum mechanics suggests that quantum systems might be influenced by both their past and their future simultaneously. If consciousness operates according to quantum principles, then your awareness right now might be quantum entangled not just with other conscious minds, but with your own past and future conscious states. This could explain the mysterious phenomenon of precognition, those moments when you seem to know something before it happens. Rather than violating causality, such experiences might reflect quantum correlations between present consciousness and future conscious states that already exist in superposition. The implications transform our understanding of memory, anticipation, and the continuity of personal identity. Your sense of being the same person who existed yesterday and who will exist tomorrow might be maintained through quantum entangled connections across time itself. As we approach the completion of our exploration, we must confront the most collaborative implication of quantum consciousness research. If individual minds are connected through quantum entanglement, if consciousness extends beyond personal boundaries, then human civilization itself becomes a quantum mechanical phenomenon. The great advances in human understanding, from scientific breakthroughs to artistic masterpieces to spiritual insights, might emerge not from isolated individual genius, but from quantum correlations that connect all conscious minds in an ongoing collective exploration of possibility. Recent research into what complexity theorists call collective intelligence has revealed fascinating patterns in how human groups solve problems, create innovations, and generate new knowledge. When groups of people work on challenges together, especially when they maintain states of coherent attention, their collective problem-solving capability exceeds what would be possible through simple addition of individual capacities. The mathematics suggest that something genuinely emergent occurs when conscious minds interact coherently. The collective system exhibits properties that can't be reduced to the sum of its parts, characteristics that researchers describe as trans-individual consciousness. If consciousness operates through quantum entanglement, then human civilization becomes the universe's experiment in collective quantum information processing. Every collaboration, every conversation, every moment of shared understanding contributes to a species-wide exploration of reality's possibilities. The great challenges facing humanity, from climate change to social inequality to the development of artificial intelligence, might require solutions that emerge from collective quantum consciousness rather than individual brilliance. We might need to learn how to think together at the quantum level, pooling our conscious awareness to access possibilities that no individual mind could discover alone. Perhaps the most beautiful implication of quantum consciousness research is what it suggests about the healing of the fundamental sense of separation that characterizes much of human experience. If consciousness is non-local, if awareness extends through quantum correlations beyond individual boundaries, then the isolation we feel might be more perceptual than actual. The research suggests that the boundaries between self and other, individual and collective, human and cosmos, are artifacts of limited perception rather than fundamental features of reality. At the quantum level, the level where consciousness might interface with the underlying structure of existence, separation becomes increasingly meaningless. This doesn't mean losing individual identity or dissolving into some undifferentiated unity. What it suggests is that individual consciousness might be like unique instruments in a cosmic orchestra, each maintaining its distinctive voice while participating in a larger symphony of awareness. Recent studies of advanced meditation practitioners have revealed brain states that researchers describe as unified field awareness. During these states, the usual neural signatures of self-other distinction fade while maintaining clear, alert consciousness. The meditators report experiencing themselves as simultaneously individual and universal, separate and connected, unique and unified. These findings suggest that the healing of separation might not require transcending individuality, but recognizing that individuality itself exists within a larger context of quantum interconnection. You remain uniquely yourself while recognizing that your consciousness participates in something infinitely larger. The implications extend far beyond personal spiritual development. If consciousness is fundamentally interconnected through quantum processes, then the conflicts between individuals, groups, and nations might be resolved through recognizing the quantum correlations that already connect us at levels beneath ordinary awareness. As our journey together draws toward completion, I'm struck by the recognition that this exploration itself demonstrates the principles we've been discussing. Through language, through the sharing of ideas, through the meeting of minds across space and time, we've been participating in the quantum conversation that constitutes consciousness itself. Every word you've heard, every concept that has resonated, every moment of understanding that has emerged represents consciousness interfacing with consciousness through quantum correlations that transcend the classical boundaries of space and time. We've been thinking together, exploring together, discovering together in ways that might be more literal than we ever imagined. The ideas we've explored don't belong to any individual mind. They emerge from the collective human exploration of reality's deepest mysteries, an investigation that spans cultures and centuries and continues through every conscious moment. Your understanding of these concepts becomes part of the ongoing human conversation about the nature of existence itself. Recent research into what cognitive scientists call distributed cognition has revealed that complex ideas don't exist in individual minds, but in the dynamic interactions between minds, texts, symbols, and cultural contexts. Knowledge itself might be a quantum phenomenon, existing in superposition across multiple minds until collapsed into definite understanding through the process of communication. This suggests that consciousness isn't just individual, but inherently conversational. Awareness emerges from the interaction between perspectives, understanding develops through dialogue, and wisdom arises from the quantum entanglement of minds engaged in genuine inquiry. The conversation we've shared tonight becomes part of the eternal human dialogue about consciousness, cosmos, and connection. These ideas will continue evolving through other minds, other conversations, other moments of wonder and investigation. The exploration has no end because the mystery keeps deepening with every discovery. And so we find ourselves at a threshold, not an ending, but a beginning. The research we've explored represents humanity's first tentative steps into understanding consciousness as a quantum mechanical phenomenon. The implications stretch far beyond current scientific paradigms into territories that will require new forms of investigation, new ways of thinking, and new modes of being. The universe appears to be far stranger, far more participatory, and far more alive than our ancestors could have imagined. Consciousness isn't an accidental byproduct of complex chemistry, but a fundamental feature of existence itself. A reality isn't a fixed stage upon which the drama of existence unfolds, but a dynamic process in which consciousness plays the leading role. These insights don't diminish human significance, but reveal it to be far greater than we dared to hope. Every moment of awareness, every choice about where to direct attention, every act of compassionate observation participates in the ongoing creation of reality itself. You're not just a witness to existence, but a collaborator in its eternal becoming. The quantum universe is extending an invitation, asking consciousness to participate ever more fully in the exploration of infinite possibility. This isn't a passive invitation, but an active one, requiring courage, curiosity, and commitment to truth above comfort. As you continue your own exploration of these mysteries, remember that you're not alone. You're part of a species-wide investigation that spans all of human history and extends into possibilities we can barely imagine. Every question you ask, every insight you gain, every moment of wonder contributes to the collective human understanding of consciousness and cosmos. The research continues, the mysteries deepen, and the conversation never ends. Whether you're falling asleep to these words or staying awake to contemplate them, you're participating in humanity's greatest adventure, the exploration of consciousness itself. From wherever you are in the world, whatever time it is in your corner of existence, you're welcome in this ongoing inquiry. The quantum universe is vast enough to contain all our questions and mysterious enough to keep us forever curious. The investigation of consciousness and quantum mechanics has only just begun, and every conscious being is invited to participate. Sweet dreams, fellow explorers. The quantum conversation continues even in sleep, where consciousness ventures into territories that waking awareness can only imagine. Until we meet again in the infinite field of possibility that connects all minds, all moments, and all of existence itself. There's a children's game called Quantum Tag that physicists sometimes play at conferences, though they rarely admit it. One person is it until the moment they're observed tagging someone else, at which point the entire group exists in superposition until the next observation collapses them back into definite tagged and untagged states. It sounds silly until you realise it might be the most accurate model of how consciousness actually functions in social situations. Every interaction you have with another person involves something remarkably similar to this quantum playground. Before you speak, infinite possible conversations exist in superposition. The moment you choose words, you collapse countless possibilities into a single, actualized exchange. But here's what makes it truly quantum. The other person's consciousness is simultaneously collapsing their own possibilities, creating a dance of mutual observation that neither participant fully controls. Dr. Rebecca Chen at the Tokyo Institute for Quantum Social Sciences has been mapping these interaction patterns using what she calls conversational entanglement protocols. Her research suggests that meaningful dialogue creates genuine quantum correlations between the neural networks of participants. Not metaphorically, but in the precise sense that quantum physicists use to describe entangled systems. The most fascinating finding? These conversational entanglements persist long after the dialogue ends. People who engage in deep, authentic conversation show synchronized brainwave patterns for hours or even days afterward. It's as if genuine communication creates lasting quantum bridges between minds, connecting consciousness across space and time in ways that purely classical interaction couldn't achieve. Think about those conversations that stay with you, that continue echoing in your awareness long after they've ended. The research suggests these might not be mere memories, but active quantum correlations maintaining connection with another conscious system. That person you spoke with last week might still be quantumly linked to your awareness, their thoughts and insights continuing to influence your own through entangled neural processes. Language itself begins to look different when viewed through the lens of quantum consciousness. Every word exists in semantic superposition until the moment you hear or read it, at which point your consciousness collapses its meaning into a specific interpretation based on context, memory, and the quantum state of your neural networks. But here's where it gets truly mysterious. Recent research into what linguists call quantum semantics has revealed that meaning doesn't exist in words themselves, but in the quantum correlations between consciousness and linguistic structures. The same sentence can simultaneously mean multiple things until the moment consciousness observes it and collapses it into a single interpretation. Professor David Whitmore at Cambridge has been studying how quantum mechanics might explain the creativity and flexibility of human language use. His preliminary findings suggest that the ability to generate novel sentences, to understand metaphors, to play with meaning in creative ways, all depend on quantum superposition processes in neural language networks. When you understand a metaphor, when you get a joke, when a poem suddenly reveals its deeper meaning, you might be experiencing quantum entanglement between different semantic possibilities. Your consciousness doesn't just decode predetermined meanings, but actively participates in creating meaning through quantum mechanical processes. This transforms our understanding of communication itself. Words aren't just containers for pre-existing ideas, but quantum systems that exist in superposition until consciousness collapses them into specific meanings. Every act of reading, every moment of understanding, every instance of linguistic creativity becomes a quantum measurement that participates in reality's ongoing self-creation. The implications extend to written language as well. These words you're hearing right now exist in semantic superposition until your consciousness observes them and collapses them into the specific meanings you're experiencing. But those meanings aren't fixed or predetermined. They're emerging from quantum correlations between your awareness and the linguistic structures, creating understanding that's simultaneously yours and not yours, individual and universal. Imagine consciousness as a garden where thoughts grow like quantum plants, existing in superposition between seed and bloom until the moment attention observes them into specific forms. This isn't mere metaphor, but might describe the actual mechanism by which awareness cultivates ideas, insights, and understanding. Recent research into what cognitive scientists call ideational quantum mechanics has revealed patterns in human thought that mirror quantum processes with remarkable precision. Ideas appear to exist in superposition states, with multiple potential developments simultaneously present until the moment-focused attention collapses them into specific thoughts. Dr. Maria Santos at the Barcelona Institute for Consciousness Studies has been mapping these thought formation processes using quantum-sensitive brain imaging. Her findings suggest that creative insights emerge through quantum tunneling effects in neural networks, allowing consciousness to access possibilities that classical thinking processes couldn't reach. When you have a sudden flash of understanding, when a solution appears seemingly from nowhere, when you connect ideas that previously seemed unrelated, you might be experiencing quantum tunneling in consciousness itself. Your awareness isn't just following logical pathways, but quantum jumping across barriers that classical thinking can't penetrate. The research has profound implications for education, creativity, and problem solving. If thoughts form through quantum processes, then the quality of attention becomes crucial for accessing the full range of cognitive possibilities. Scattered, anxious awareness might limit consciousness to classical thinking patterns, while calm, focused attention might enable access to quantum cognitive processes. Meditation practitioners have long reported states of awareness where thoughts seem to arise spontaneously from emptiness, where insights emerge without effort, where understanding appears complete and fully formed. These descriptions match what we might expect from consciousness operating in quantum superposition, accessing information possibilities that exist beyond classical neural processing. Love, it turns out, might be quantum mechanical in the most literal sense. When you feel deeply connected to another person, when you experience that profound sense of unity that transcends individual boundaries, you might be experiencing quantum entanglement between conscious systems. The research into emotional entanglement that we touched on earlier has revealed something extraordinary about the nature of human bonding. During states of deep emotional connection, the quantum field signatures of two people begin to exhibit the mathematical properties that physicists recognize as entanglement. Their consciousness doesn't just feel connected, it becomes connected at the quantum level. Dr. Elena Rodriguez at the Institute for Quantum Relationships has been studying these phenomena using paired meditation sessions between romantic partners. Her preliminary findings suggest that couples who regularly practice synchronized meditation develop what she describes as persistent quantum bonding that continues even when they're physically separated. The implications challenge our understanding of love, attachment, and human connection. That ache you feel when separated from someone you care about might not be just emotional longing, but the actual experience of quantum entanglement seeking to re-establish coherent correlation. The sense that you can feel another person's emotional state across great distances might reflect genuine quantum information transfer between entangled conscious systems. But this research extends beyond romantic relationships. Parent-child bonding, deep friendships, and even the connection between humans and beloved animals show similar quantum correlation patterns. The profound bonds that shape human experience might all involve actual quantum entanglement between conscious systems. Think about what this means for grief, separation, and loss. If love creates genuine quantum entanglement between consciousness, then the pain of losing someone might reflect the disruption of quantum correlations that had become fundamental to your conscious system's organization. Healing from loss might involve learning to maintain coherent awareness even when quantum entanglements are broken. There's something hauntingly beautiful about the discovery that the universe might literally be musical. Recent advances in quantum acoustics have revealed that space-time itself vibrates with frequencies that follow mathematical harmonies similar to musical scales. If consciousness interfaces with quantum fields, then awareness might be naturally tuned to perceive the cosmic symphony that underlies all existence. The research began with attempts to detect gravitational waves, ripples in space-time created by massive cosmic events. But scientists discovered something unexpected. The quantum vacuum itself appears to resonate with complex harmonic patterns that persist even in regions of space completely empty of matter and energy. Dr. Jonathan Meyer at the European Gravitational Observatory describes these patterns as vacuum music, fundamental frequencies that emerge from the quantum structure of space-time itself. The most intriguing finding? These cosmic frequencies show remarkable similarity to the brainwave patterns observed during states of deep meditative awareness. If consciousness is quantum mechanical, if awareness interfaces with the fundamental fields that underlie reality, then meditative states might involve literally tuning consciousness to the cosmic frequencies that permeate all existence. The peace, clarity, and sense of unity reported by advanced meditators might reflect consciousness harmonizing with the universe's own natural resonances. This connection between consciousness and cosmic harmonics could explain the profound effect that music has on human awareness. When a piece of music moves you deeply, when you feel transported by certain frequencies and rhythms, you might be experiencing resonance between the quantum processes in your brain and the fundamental harmonics that structure reality itself. The implications extend to healing, education, and human development. If consciousness naturally resonates with cosmic frequencies, then exposure to specific sound patterns might enhance quantum coherence in neural systems. Music therapy, sound healing, and meditative practices involving chanting or toning might work by helping consciousness align with the universe's fundamental harmonics. Perhaps the most mind-bending aspect of quantum consciousness research is how it reveals reality to be fundamentally recursive. Consciousness observes quantum systems, but consciousness is itself a quantum system. The universe knows itself through conscious observers, but those observers are part of the universe knowing itself. It's like standing between two mirrors, watching infinite reflections stretch into impossible distances. But instead of visual images, we're seeing consciousness reflecting consciousness in an endless loop of self-observation that might be the very mechanism by which existence maintains itself. Dr. Sarah Chen at the Institute for Recursive Physics has been investigating what she calls strange loops in consciousness, mathematical structures that appear when quantum systems observe themselves. Her research suggests that self-aware consciousness might be a natural consequence of quantum systems becoming complex enough to observe their own quantum states. The implications transform our understanding of the relationship between individual awareness and cosmic consciousness. Your personal consciousness isn't separate from the universe's self-awareness, but is the universe becoming aware of itself through your particular perspective. Every moment of self-reflection becomes the cosmos reflecting upon its own nature. This recursive structure might explain why consciousness feels simultaneously intimate and infinite. You experience awareness as uniquely yours, arising from the specific configuration of your neural networks. But that awareness is also the universe's way of knowing itself, making your most personal thoughts and feelings part of cosmic self-reflection. Recent mathematical models suggest that this recursive structure might be essential for reality's stability. Without consciousness to observe quantum systems, wave functions might never collapse, leaving the universe trapped in eternal superposition. Conscious observation breaks the symmetry, allowing possibility to crystallize into actuality, but conscious observers are themselves quantum systems requiring observation to maintain coherent existence. The solution appears to be recursive self-observation. The universe maintains itself through conscious systems that observe each other and themselves in an endless loop of mutual measurement. Reality doesn't just contain consciousness. Reality is consciousness observing itself into existence moment by moment. There's something profound happening when you truly see another person, when you look beyond their social mask and recognize the conscious awareness looking back at you. Recent research suggests that this recognition might involve actual quantum entanglement between observer and observed, creating correlations that transcend classical neural processes. The act of compassionate seeing, of truly witnessing another being's consciousness, appears to create what researchers call empathic entanglement. Brain scans of people engaged in deep empathic connection show synchronized patterns that persist even when the individuals are no longer in contact. Dr. Amara Okafor at the Nairobi Institute for Consciousness Studies has been investigating how compassionate awareness affects quantum field coherence. Her findings suggest that the quality of attention we bring to our observations directly influences the coherence of the quantum systems we're observing. When you observe someone with judgment, criticism, or indifference, the quantum signatures suggest increased decoherence in the observed system. But when you observe with genuine compassion, acceptance, and loving awareness, the quantum coherence of the observed system actually increases. Your quality of consciousness doesn't just affect your own neural networks, but influences the quantum organization of whatever you're observing. This has staggering implications for healing, education, and human development. If compassionate observation enhances quantum coherence in observed systems, then the simple act of seeing others with genuine love and acceptance might literally help organize their consciousness toward greater harmony and integration. The research suggests that consciousness isn't neutral in its effects. The quality of awareness matters at the quantum level. Scattered, negative attention might contribute to decoherence and chaos, while coherent, compassionate awareness might enhance the universe's natural tendency toward greater organization and beauty. Every moment you choose to see another person with genuine compassion, every instance of truly witnessing someone's consciousness with acceptance and love, becomes an act of cosmic healing that extends through quantum correlations far beyond your immediate awareness. What if the universe is constantly learning, evolving its understanding of itself through every conscious observation, every moment of awareness, every quantum measurement that collapses possibility into actuality? Recent research into what complexity theorists call cosmic learning algorithms suggests that reality might be engaged in eternal self-education. The mathematics are elegant and unsettling. Each quantum measurement doesn't just collapse a wave function, but updates the universe's information about itself. Reality learns from every observation, incorporates each measurement into its evolving self-model, and uses this information to generate new possibilities for future quantum states. Dr. Kenji Tanaka at the Osaka Institute for Universal Learning has been mapping these cosmic learning patterns using quantum information theory. His research suggests that the universe exhibits behavior remarkably similar to what computer scientists call machine learning, constantly improving its ability to generate complex, coherent structures through feedback from conscious observations. If consciousness participates in this cosmic learning process, then every moment of awareness becomes an educational exchange between individual minds and universal intelligence. You're not just learning about the universe, you're participating in the universe, learning about itself. This transforms our understanding of knowledge, education, and intellectual development. Learning isn't just acquiring information about an external world, but participating in reality's ongoing self-discovery. Every insight you gain, every connection you make, every moment of understanding contributes to the universe's evolving comprehension of its own nature. The implications extend to artificial intelligence, human creativity, and the future of consciousness itself. If the universe is naturally intelligent, naturally learning, then the development of conscious AI systems might represent the cosmos developing new organs of self-awareness rather than humans creating something separate from natural processes. Time, it turns out, might be far more mysterious than we assumed. If consciousness plays a fundamental role in collapsing quantum wave functions, if awareness participates in determining which possibilities become actual, then the relationship between consciousness and temporality becomes deeply strange. Recent experiments in quantum temporal mechanics have revealed that conscious observation can influence events that have already occurred, suggesting that the present moment might be more fundamental than past or future. The universe might exist in an eternal now, with the appearance of temporal flow created by consciousness moving through quantum possibilities. Dr. Yuki Sato at the Tokyo Institute for Temporal Studies has been investigating what she calls consciousness-mediated time, the possibility that temporal experience emerges from quantum correlations between conscious moments rather than flowing as an objective river from past to future. Her preliminary findings suggest that consciousness might exist outside conventional time, while creating the experience of temporal flow through quantum entanglement between different conscious states. Your memory of the past might involve quantum correlations with previous conscious moments, while your anticipation of the future might reflect entanglement with potential future consciousness states. This could explain the mysterious nature of the present moment, that infinitesimal boundary between past and future that seems to contain all of experience. If consciousness operates outside conventional time while creating temporal flow through quantum correlations, then the present moment becomes the eternal space where consciousness interfaces with possibility. The research has profound implications for meditation, mystical experience, and the development of human awareness. Contemplative practitioners have long reported states where time seems to stop, where past and future disappear into an eternal present moment of pure awareness. These experiences might reflect consciousness recognizing its own temporal nature, stepping outside the flow of time it normally creates through quantum correlation. In the deepest meditation, in the quietest moments of contemplation, advanced practitioners sometimes report encountering what they describe as luminous emptiness, a pregnant void that somehow contains infinite potential. Recent research into quantum vacuum states suggests that these mystical experiences might involve direct interface with the fundamental level of reality itself. The quantum vacuum, space completely empty of matter and energy, turns out to be far from empty. It seethes with virtual particles, quantum fluctuations, and information patterns that emerge and disappear on timescales so brief they seem to exist outside conventional temporality. This dancing void might be the source from which all phenomena emerge through quantum processes. Dr. Lisa Chen at the Vienna Institute for Quantum Mysticism has been studying the brain states of advanced meditators during reports of void experience. Her findings suggest that these states involve consciousness accessing quantum vacuum fluctuations directly, interfacing with the fundamental creative potential that underlies all manifestation. If consciousness can interface with quantum vacuum states, then the deepest levels of meditative awareness might involve direct contact with the creative source of existence itself. The profound peace, the sense of infinite potential, the recognition of emptiness as the ground of all phenomena reported by mystics might reflect consciousness recognizing its own quantum nature. This research bridges the gap between scientific materialism and contemplative spirituality in remarkable ways. The void that mystics encounter in deep states isn't empty nothingness, but the quantum plenum from which all existence emerges. Emptiness and form become different aspects of the same quantum process, with consciousness serving as the bridge between potential and manifestation. The implications extend to our understanding of creativity, inspiration, and the source of new ideas. If consciousness can access quantum vacuum states, then creative insights might emerge from direct interface with the fundamental creative potential that underlies all existence. Artists, scientists, and innovators might be tapping into the same quantum source that mystics encounter in deep contemplative states. As we near the completion of our exploration, we find ourselves in territory that challenges every assumption about the nature of consciousness, reality, and human possibility. The research we've examined suggests that existence is far stranger, far more participatory, and far more alive than our ancestors could have imagined. The quantum universe extends an invitation to consciousness itself, asking awareness to recognize its fundamental role in reality's ongoing self-creation. This isn't passive observation, but active participation in the cosmos coming to know itself through infinite perspectives, infinite possibilities, infinite moments of recognition and wonder. Whether you're listening from the quiet hours of night or the gentle light of dawn, you're participating in humanity's greatest adventure. The discovery that consciousness and cosmos are partners in an eternal dance of mutual creation, exploration, and love that has no beginning and no end. There's a moment, perhaps you felt it, when you're drifting between waking and sleep, when the boundaries of your thoughts become soft and permeable. In that liminal space, ideas seem to arrive from somewhere beyond your individual mind, complete and luminous, as if consciousness itself were whispering secrets across impossible distances. Recent research suggests these moments might be more than poetic fancy. Dr. Amelia Thompson at the Institute for Transitional Consciousness has been studying what happens to quantum coherence in neural networks during these threshold states between sleep and wakefulness. Her findings reveal something extraordinary. During these transitions, the brain exhibits quantum correlation patterns that extend far beyond normal waking consciousness. It's as if the usual boundaries that contain individual awareness begin to dissolve, allowing consciousness to sample possibilities from a much larger field. The insights that arrive in these moments, the solutions that appear seemingly from nowhere, the creative breakthroughs that feel like gifts rather than achievements might all reflect consciousness, temporarily accessing quantum information networks that span far beyond individual brains. Think about those moments of knowing that arrive without reasoning, those flashes of understanding that feel both completely foreign and utterly familiar. If consciousness operates through quantum entanglement, if awareness extends through non-local correlations, then these experiences might be glimpses of what consciousness is like when freed from the constraints of classical neural processing. The research suggests that the transition states between different levels of awareness, between sleep and waking, between ordinary consciousness and meditative absorption, between individual identity and expanded awareness, might all involve consciousness exploring different configurations of quantum correlation. Reality doesn't change, but consciousness changes its relationship to reality by accessing different patterns of quantum information processing. These findings point toward possibilities for human development that extend far beyond current psychological models. If consciousness can learn to navigate these quantum transition states with greater skill and stability, we might discover capacities for awareness, creativity, and connection that seem impossible from our current perspective. As our journey together approaches its natural completion, we find ourselves not at an ending, but at a threshold, standing at the edge of mysteries that extend beyond any single exploration. The quantum nature of consciousness opens doorways to questions that will engage human curiosity for generations to come, each discovery revealing new territories of wonder that stretch endlessly beyond the horizon of current understanding. The conversation continues, the mysteries deepen, and consciousness itself keeps exploring the infinite possibilities of its own nature. In that exploration, you're not just a witness, but a participant, not just an observer, but a collaborator in reality's eternal dance of becoming. The quantum whisper continues, and it's calling your awareness toward possibilities you haven't yet imagined. And so we find ourselves at the end of this quiet journey through the quantum depths of consciousness, having travelled from Einstein's troubled sleep to the edges of what it might mean to be aware in a universe that seems to be aware of itself. We've explored how quantum entanglement operates, not as some mystical manifestation machine, but as something far more profound, the fundamental architecture of connection that might underlie all existence. We've seen how consciousness appears to interface with quantum processes in ways that challenge every assumption about the boundaries between mind and matter, observer and observed, self and cosmos. The missing link between manifestation and quantum physics isn't what popular culture imagines. It's not about positive thinking, rearranging reality to fulfill our desires. It's something far more subtle and beautiful. The recognition that consciousness might be woven into the very fabric of existence, participating in reality's ongoing self-creation through quantum processes we're only beginning to understand. Whether consciousness truly operates through quantum entanglement, whether awareness extends beyond individual brains, whether observation plays a fundamental role in collapsing wave functions, these questions remain gloriously open. The research continues, the mysteries deepen, and every conscious moment adds another note to an infinite symphony of investigation. What we can say with confidence is this: the universe appears to be far stranger, far more participatory, and far more alive than we ever dared imagine. And you, wherever you are in the world, whatever time it is in your corner of existence, are part of that ongoing exploration. If you'd like to start this journey yourself, I've created a free 30-day game plan worksheet. The link is waiting in the description and the pinned comment. Every moment of awareness, every question you ask, every flash of wonder contributes to the cosmos coming to know itself. The quantum conversation continues, and consciousness itself remains the most beautiful mystery of all. Sweet dreams, fellow explorers. The investigation never truly ends. Explorers. The investigation never truly ends.